section is solving quadratics using any method. So what we're going to do is go through the methods that we've studied in class and just review them and talk about when we would use each of them. So the first method that we did is factoring. This one we should probably be the most familiar with because we spent quite a bit of time on this before we left for the shelter in place. So factoring, as far as when you're solving a quadratic, that is always my first choice. So if you are given a quadratic to solve, I always like to see if factoring can work just because it's quick and easy. And when I say if it works, remember you have to have two numbers that multiply to something and add to another number. So as a review of factoring, the first step that you want to do is draw your box. And then you put the first term in the first box, the last term in the last box, and then you make your diamond. So 6x squared goes on top, and you take your middle term, which is 5x, and put that at the bottom. And you need two numbers to multiply to 6x squared and add to 5x. So if you had a quadratic and you wanted to solve it and you tried factoring, but you couldn't find those two numbers and nothing worked, that is when you would try an alternative method. But I like to say factoring is my first choice, and then if I can't find anything, I'll do something after. So I take those two numbers and place them in the diagonal boxes, and then I come up with the edges. So we have x, x, and then 2 and 3. So my factors are x plus 2 and x plus 3. And remember, this whole thing is equal to 0. And then using the zero product property, we could separate these and set them both equal to 0. So we would have to subtract 2 and subtract 3. So we get x equals -2 and x equals -3. So there are two solutions, which means the graph crosses the x-axis at both -2 and -3. So this is a review of factoring. I am going to put a little note here that's important to know that not every quadratic can factor. So remember, this might be a lot of your guys' first choice, but if it doesn't factor, then you need to try something else. So we're going to talk about the other methods. So the next method that we talked about was taking the square root. So this is also another quick and easy method, but it doesn't always work. So looking back at this first example, x squared plus 5x plus 6, we can't take the square root because we have two different x's, so there's no way to really isolate the x. But in this problem, we're missing a b value, so this makes a perfect choice for taking the square root because we're able to isolate the x. So in taking the square root, you're isolating the x and solving for it. So we would add the 12 and we get 3x squared equals 12. You divide by 3, and then you get x squared equals 4. And then the last step is to take the square root. So you take the square root of both sides, and you get x equals plus or minus 2. So really x equals +2 and -2. So two solutions. Looking at the example on the right, this is another great option for taking the square root because it's in vertex form. So I'm able to isolate the x by subtracting 5 first. So you get x minus 1 squared equals 11. Now in order to undo that squaring, I have to take the square root. So I get x minus 1 equals plus or minus the square root 11. And the last step is to just add that 1. So we get x equals plus or minus root 11 and then plus 1. So again, that's two solutions. It's positive root 11 plus 1 and negative root 11 plus 1. And a couple of important things about taking the square root when you would want to use it. So you would want to use when the equation is in vertex form. So I should say use when in vertex form. Just like the one on the right, it made it simple. The other time that you would want to use it is when it's in standard form. but there is no b value. So use one in standard form, but no b value. So remember, standard form is ax squared plus bx plus c. So there's no middle term. So again, ax squared plus bx plus c. So we're missing that term, so we're able to solve it by taking the square root. All right, the next method, which we have practiced a lot, is completing the square. So we use completing the square to solve, but we also use completing the square to put it into vertex form. So because of that, we actually have practiced this a lot. This one's it takes a little bit longer than if we were to take the square root. Completing the square will always work, but sometimes it might be trickier than others, or you might get weird numbers. But the a value has to be 1. So again, going back to the ax squared plus bx plus c, that first constant or coefficient must be 1 in order to do it. And if it's not, then you have to divide. So going back to what I originally said, when you're given a quadratic to solve, I like to first do factoring. If that doesn't work, then maybe you can try completing the square. But with completing the square, the other thing that makes it easier is if that middle term is even, because you have to split it in half. So let's go ahead and review the process of completing the square. So the first thing that we want to do is move that 2 to the other side, and then when I do that, it becomes negative because it's like subtracting. And then I'm going to come up with a new c value, so I'm going to do that on both sides. From there, you create your box, and you put the first term in the first box. You split the 6x in half, and it becomes 3x and 3x. You come up with your edges, and then you complete the square. So 3 times 3 is 9. So I'm going to go ahead and place that in the blanks. Next, we write down the factors. So since I have x and 3 on both sides, I would say it's x plus 3 squared equals, and then we have negative 2 plus 9, which is 7. Now, if I were putting this in vertex form, I would subtract the 7, but what I'm trying to do is isolate the x. So in order to do that, I would have to square root both sides. So we get x plus 3 equals plus or minus the square root of 7. And then from there, I would want to subtract the 3. So we get x equals plus or minus the square root of 7 plus 3. Or sorry, minus 3. Okay, so again, this has two answers. We have positive root 7 minus 3 and negative root 7 minus 3. So let's talk about a couple of those important things when you would want to use completing the square and what are the rules. So remember, a must be 1. And the other thing we said, it's helpful when b is even. So it's not necessary though. It doesn't have to be, but it is helpful. And then the last thing is, I would say, is use this when you can't factor, because I think most of us feel most comfortable with factoring, so that should be option 1, but if you can't factor, then maybe you go to this. All right, the last method, method 4, is the quadratic formula. So I have it written out here just as a review. So x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So this method is great because it works every time, no matter what, okay? So the first step that we do is identify what a, b, and c is. So it must be in standard form. So our a value is 2, our b value is negative 1, and c is negative 15. And then it's pretty simple because you are just plugging it into a formula, but the formula's not the easiest formula, so you have to be careful. So we get x equals negative b. Since b is already negative, it's going to be x equals 1. And then we have plus or minus the square root. B squared would be negative 1 squared, which is 1, minus 4, and then a times c. So that would be 2 times negative 15, which is negative 30. And this is all over 2 times a, which is 2 times 2. So we then get x equals 1 plus or minus the square root of 1. Negative 4 times negative 30 is positive 120. And this is all divided by 4. We continue to go, and we get x equals 1 plus or minus the square root of 121 divided by 4. And then lastly, we could actually find the square root of 121, which is 11. So we get 1 plus or minus 11 divided by 4. And then you would separate this. So think of it as 1 plus 11, which is 12 over 4. So we would get x equals 3. The other one would be 1 minus 11, which would be negative 10 over 4. So we get x equals negative 5 halves. Okay, so let's talk about a few of those items that we talked about in the beginning. So in order to use the quadratic formula, you want to have it in standard form, meaning the ax squared plus bx plus c. So that way you can clearly identify your a, b, and c. The other important thing is that it always works, okay? Sometimes you might not have a b value or a c value, but then you would just plug in 0. And then once again, I'm going to say use when you can't factor. So now it's up to you what method you want to use, and like we talked about, the different uses and when you should use them, but you need to use what's most comfortable for you. And now you have all of these tools to do that. So that's all the methods for solving a quadratic.